you're welcome to elaborate if you'd like, but let me read what you say. Hi, Randy. How would you apply this style of teaching and these techniques to make more abstract maths accessible, for example, with final year students?
I think the key to it is, and we have to accept that there is a lot of abstraction in math, and that's necessary. And a lot of things that we find, a lot of topics that we find in math, there's no other way to describe it than abstractly. But I think if we start with our students at a young age and get them to understand math at a conceptual level and use things like reintroducing the language aspect into math, that will get them a lot more comfortable with math. And by the time they get older, they're much more willing and are able to understand the abstract concepts. But if we start off with pure abstract too early when they're younger, then as they get older, they'll automatically have a dislike towards mathematics. So I think the key to that is starting them young, getting them to develop that math mindset early. And when we do get to abstraction, then it becomes a lot more easier to do that.
Hi, Randy. Yes, thank you for that. The reason that I'm very curious about this specifically is not too long ago, a friend in computer science heard about topology. And so I tried to explain what a topology is. And it was very difficult explaining abstractly. So I took a little time to think about how can I make this more accessible. And I started thinking a lot about like jars, like people putting different things in different jars, like the nuts in this jar and the apples in that basket and so on, and like splitting it up like that. And then I found a way to kind of correlate it towards topology, and that worked wonders. And then I had them explain it back to me like perfectly and make their own examples with other, maybe not fruits and things, but other worldly things. So with topology, I was able to do that, but that made me think, how would you be able to do it with other things? And your presentation reminded me now about that. So thank you for your wisdom.
Thank you. Thank you.
We have a very similar type of question. I think that oh, I've lost it now. It's coming here from Elizabeth. But it seems that you've answered part of this question as well, but it's good to see that it's a common idea that's coming through. I like the idea, Elizabeth says, of putting mathematics as a human language. Is it possible to use this technique to teach all mathematical subjects? Because some subjects seem to be more abstract. So it's also thinking about the abstract side of maths, which is more of a challenge to get across the understanding. But obviously, algebra is something that appears to be the most abstract. Yeah, I don't know if there's any more you'd like to add to that.
Well, I don't think that we can explain all of mathematics in the same way, but there's many different aspects of it that do make sense, that makes sense to teach that way. And I'll put my document camera back on. And here's an example, or a couple of examples actually. Okay, so document camera is back on. Let me know if it's not.
Yes.
So the whole apples plus apples concept. One apple plus one apple equals two apples. 1/3 plus 1/3 equals 2/3. It works for fractions. It works for physical objects. It also works for exponents. So here, 7x squared plus 2x squared, just like apples plus apples give you apples. X squared plus x squared gives you x squared. How many x squared? 9x squared. And if you think about this, what is a common mistake that students make when they first learn about adding exponents? Sometimes they think that x squared plus x squared gives you x to the 4th, which is incorrect. But if you start with apples plus apples, then they don't make that mistake. So that same concept can be applied to the idea of exponents. It can be used with place value as well. So billions plus billions give you billions, and that's why it's important to line up place values. And even when you're working with money, so here's a money example. Let's say this is $4.23 plus $1.34. That explains why it's important to line up the decimal points when you're adding decimals. Because if I slide it over, dollars can only go with dollars, cents can only go with cents. What's the easiest way to make sure that dollars only go with dollars and cents go with cents? There you go, line up the decimal points. So that concept of apples plus apples has many different applications. It works with exponents, it works with place value, it works with money and decimals as well. And that's why when you see a problem like x squared plus y to the fourth, for example, they're not like terms. They don't have the same name. So that's why you cannot do a problem like this. So that lesson about apples plus apples is one of the most important lessons that I teach, because further down the line, when we learn about things like exponents, it still comes into play.